a problem that's looking to find what is an impossible score. They've given you a simple dartboard where the center value hitting the center is worth 7 points. I miswrote that. And the outer ring is worth 5 points. And they want to know what is the highest, largest, impossible score for you to get. In order to figure this out, what we're going to need to do is we need to figure out how to calculate our score. Calculating the score is going to be 5 times the outer ring plus 7 times the inner ring. And this is the number of hits for each. So if I have 0 hits on the inner ring, it would be 5 times the outer. If I had 1 hit on the inner ring, it would be 5 times outer plus 7. And plus 14 for 2 hits, and plus 21, and so on down to 4 hits. Now I'm not going to calculate 5 hits because at that point I'm into the 5s times tables and not the 7s. So I can set all of these equations equal to 28 and solve to figure out what the remainder is. For the first one, there's 5 5s in 28 and 3 left over. That means I have a remainder of 3, and 3 is an impossible score. On the second one, I subtract 7 from both sides, giving me 5 times the outer is equal to 21. There are 4 5s in 21, leaving 1 left over, a remainder of 1, so 1 is an impossible score. And continue this down the rest of these equations, giving me impossible scores of 4, 2, and 0. Remember, this is about finding the impossible score. Now that I know what the maximum score I can get with those multiples of 20 or of 7 to get 28, I'm going to start looking at lower values like 27 being made up of 5s and 7s. 27 is made of 4 5s and 1 7. So I'm going to look at 26. 26 is made of 1 5 and 3 7s. 25 is made of 5 5s and 0 7s. 24 is made of 2 5s and 2 7s. And 23 has no combinations of 5s or 7s that can make it. So 23 becomes our largest impossible answer, and we can see this when we test a larger number. We can see 24 as an example of what we're going to use in the larger numbers. 24 is made of 14 plus 10. That's 2 5s and 2 7s. So if I was to try and find 29, 29 is found by using my values to find 14 and my values to find 15. This leads me to asking the question, does this happen in other cases? Let's try a new case where the inner ring is 9 and the outer ring is 7. I'm going to start by doing the same thing I did before, which was list my equation, 7 times my outer plus 9 times my inner. And I'm going to go down my inner values from 0 to 6, because remember, at the 7th hit, I'm counting 7s. I'm not counting 9s anymore. I'm using the same process before, where I'm going to go ahead and simplify these expressions to get 7 times my outer, 7 times outer plus 9, 7 times outer plus 18, 7 times outer plus 27, and so on. I set all the equations equal to 54, and like before, I go to find what my remainders are. I find that my first remainder is 5, my second is 3, then 1, then 6, then 4, then 2, and a remainder of 0. I know my impossible scores are 0 through 6. I now need to figure out what are my number combinations to score numbers beneath 54. 54 is my magic number. So with 54 being our magic number, I'm going to build a table for 7s and 9s that make a 53. And that's going to be the first thing that I check. To make a 53, I use 5 7s and 2 9s. A 52 is made with 1 7 and 5 9s. 51 is made with 6 7s and 1 9. 50 is made with 2 7s and 4 9s. 49 is made with 7 7s and 0 9s. 48 can be made with 3 7s and 3 9s. 47 can't be made. There's no cases, combinations of 7s and 9s. But what I'm seeing right here is very interesting. This is the 7th term. The fact that that's the 7th term, and in our previous example it was the 5th term that was our impossible number and our highest. Would this happen in every case? And if it would, how can we prove it? Well, I'm going to ask you if you can find other cases that this would work, where the impossible score is the lower score away from our magic number.